Assalamualaikum and good day. So in this video, we'll look at one of the examples on series solutions near ordinary points. Okay. For example, given to us this equation y double prime minus xy prime plus 2y equal to 0. So first, you need to determine whether x equal to 0 is an ordinary point. And B, find a recursion formula for the power series solution near x equal to 0. Recursion is the same as recurrent. So don't worry about that. This one is actually the same as recurrent. Okay, recurrence formula. And last, find the general solution of this equation near x equal to 0. Since it doesn't define here until if x power of 5 or x power of 7, you just need to determine at what point that you need to stop. Okay. And okay, the first one A. Determine whether x equal to 0 is an ordinary point. So refer to your Px. Px here is equal to 1. That's why Px equal to 1. Substitute x equal to 0 in Px. So we have P0 equal to 1. Which is does not equal to 0. And therefore, x equal to 0 is an ordinary point. Okay. Next, since it is an ordinary point, we assume that we use the power series. Okay. So we have here, you might want to skip that and just start from writing this. Okay. Let y equal to summation n equal to 0 to infinity a n s power of n, and write the y prime and also the y double prime. And then substitute y here, y prime and y double prime into the ODE. That means here should be the place of y double prime minus xy prime originally plus 2y equal to 0. So we just need to substitute the equation here. Okay, this is the y prime. Okay, and this is the y. Sorry, that one is the y double prime and this is the y prime. Okay. And the next one is 2y plus 2y. That's why here is 2 times the summation. Okay. Equal to 0 because it is equal to 0. Next, what you need to do? Expand. Okay, expand the equation. What do I mean by expand is, for this one, there is nothing for you to multiply in front of the summation. So, it will be the same. But this one, we have x at the front. So, you need to multiply x with x power of n minus 1. It will be x power of n. Remember the law of index. X power of 1 multiply with x power of n minus 1 is equal to, we need to add the power 1 plus n minus 1. That's why we have x power of n. Okay, this is just for you to recall. Okay. And then for this one, there's only 2. You have the option whether to write 2 in the summation or outside the summation. It doesn't matter here. Okay. This one just rewrite. And then next, after you have expand, you need to equate powers of x. Which means here you need to equate 2x power of n. Okay. So the first one, it actually earlier was x power of n minus 2. So, we need to change it to x power of n. So, for every n, we substitute it with n plus 2. Because n plus 2 minus 2 is equal to n. So, at every n, you just need to replace it as n plus 2. And here, originally, it was n minus 1. So, we change here n here into n plus 2. That's why n is n plus 2. And n plus 2 minus 1 will be n plus 1. Okay. And for the summation, before it starts at n equal to 2, but right now it starts from n equal to 0. Why? Because the summation here is n plus 2 equal to 2 and is equal to 0. Okay, you change that. Okay. And this one is are the same from previous equation. Okay. Next, this is also optional. If you want to substitute the value of 0 and then compiling the others later on, is also an option. Or you can directly from here to this point. That means when n equal to 0, So, substitute n equal to 0 in this summation and also the third summation. Why? Because it starts from 0. This one starts from 1. Okay, this one also starts from 0. So, we have 2a2 plus 2a naught equal to 0. And hence, we have this one. Okay, I think it should be here actually. When n equal to 0, it should be here. Okay, when n equal to 0 is there. Sorry. So here, when n equal to 0, 2a2 plus 2a naught equal to 0. So 2a2 is equal to negative 2a naught. So a2 is equal to negative a naught. Okay. Next, after that, since the summation, the highest degree, should I say degree? No. The highest starting point of the summation is at 1. That's why, in general, the recurrence formula would start from n greater than or equal to 1. Why? Because we keep repeating using the same summation for every n starting from 1. Okay. Plus, at the end, it is equal to 0, which is a homogeneous equation. So, everything gonna be equal to 0. So, it recurs using the same summations. Okay. That means we substitute n in all the summations. Okay. So, right now, since this one has been factorized, so it will be like this. N plus 2, n plus 1, a n plus 2 minus n minus 2, a of n equal to 0. Let's say you didn't do this line. Okay. So, directly from here, okay, how do we solve for recurrence formula? Just rewrite everything of this summation, but omit the summation and also x power of n. Therefore, it will be n plus 2, n plus 1, a n plus 2 minus n a of n plus 2 a of n. This one is equal to 0. Why? Because everything can be compared to 0 only. And next, n plus 2, n plus 1, a n plus 2 is equal to n minus 2 a n. Okay, this one I have factorized. Okay, I think it's better for me to rewrite it first. N a n minus 2an, and then an plus 2 is equal to n minus 2 over n plus 2 n plus 1 an. Okay, remember we need to leave the coefficient, that the biggest coefficient on the left. That's why here we have an plus 2. Same for earlier, when n equal to 0, we need to find a2 equal to what? Why? Because a2 is the highest coefficient. It's the biggest coefficient there. Okay. And this is the recurrent formula. See, it is the same. Both are the same. Okay. And then, next, you need to substitute the value of n equal to 1, which means here, substitute 1, we have a3. Okay. And hence here, 1 minus 2 is negative 1. 6 plus 2, 1 plus 2 is 3. Times 1 plus 1 is 2. That's why 1 over 6 a1. Next, when n equal to 2, substitute 2. N equal to 2, we have 2 minus 2 equal to 0. So, here 0. And then the next one, we have n equal to 3. 3 plus 2 is 5. So, a5. 3 minus 2 is 1. 3 plus 2 is 5. 3 plus 1 is 4. 5 times 4 is 20. So, an, a3. Remember what I told you in the previous video of the introduction of power series. Everything needs to be in terms of a1 and a0. So, you need to change it into a1. Therefore, from here, we should substitute a3 as negative 1 over 6 a1. Okay, that's why the value here would be negative 1 over 120 a1. There you go. It's the same one. And then n equal to 4 is a6 because 4 plus 2 is 6. And then 4 minus 2 is 2. 4 plus 2 is 6. 4 plus 1 is 5. So 6 times 5 is 30. And here is a4. Okay, so here a4 is equal to 0. So anything multiplied with 0 is equal to 0. Okay, next we just need to substitute n equal to 5 and n equal to, this one is not 8 actually, sorry. Pardon for the mistake. This should be 6. Okay, and then rewrite it as y is equal to summation n equal to 0 until infinity, which is an x power of n. And this is the expansion. Just substitute the value of the coefficients that we have obtained earlier. A2, A3, A4, A5, A6, and A7. Last, you just need to factorize A0 and A1. And this would be your final answer then. Don't forget that you need to write this term plus dot 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 because it is continuous. Okay, it doesn't end there. Okay, for this one, we don't have to write it because it just stop until S power of 2. There's no A naught anymore. Okay, thank you class. Assalamualaikum.